This video is about how to create a dot plot and stem and leaf display. So we'll start with the dot plot. A dot plot is the numerical value of each quantitative measurement in the data set, and it's represented by a dot on a horizontal scale. When data values repeat, the dots are placed above one another vertically. With the stem and leaf display, the numerical value of the quantitative variable is partitioned into a stem and a leaf. The possible stems are listed in order in a column. The leaf for each quantitative measurement in the dataset is placed in the corresponding stem row. Leaves for observations with the same stem value are listed in increasing order horizontally. The stem is the leftmost digit of a measurement. The leaf, or leaf unit, is the rightmost digit of the measurement. So let's take a look at how we can use dot plots and stem and leaf displays in statistics. Our first example for classwork today, we're going to consider this table which lists stems from 0 to 5 and leaf values are given in the next column. We want to know how many observations were in the original data set. So in order to answer that question, we need to know how the stem pairs with the leaf. So with given stem 0, that pairs with one value for a leaf. So that represents one number. We basically could just count the number of leaves, and that will tell us the number of observations. In our second row, we have a stem of 1. That actually means 1 is paired with 4 to make the number 14. 1 gets paired with 5 to make 15, and finally 1 gets paired with 7 to make the number 17. So you can see 3 different values come from 3 leaves. So let's count the leaves. You can see that we have 23 different leaves, and therefore we will have 23 observations. Part B says, in the bottom row of the stem and leaf display, identify the stem, the leaves, and the number of the original data set represented by the stem and leaves. So we will look at the stem, leaves, and the original data set represented by the stem and its leaves. So in our last row, we have stem of 5. Our leaf values are 0, 1, and 2. So when we pair each leaf with the stem of 5, we're generating the numbers 50, 51, and 52. For part C, we're going to recreate all the numbers in the data set and construct a dot plot. The original numbers in the data set are listed here. So you'll notice that the number 20 appeared 3 times, and it is important to include that value 3 separate times. And also 31 appears more than once, 39 appears more than once, so does 42. So it's important to count those or record those values that repeat each time in order to account for every value in the original data set. Now we'll construct the dot plot. So for the dot plot, we need a horizontal line. So there is our horizontal line, and we'll place our data values below that. So what would be helpful is to create a scale so that we can place our numbers. We don't want to count by ones probably, because our numbers go from 1 to 52, and that would just be too cluttered on the scale. So maybe counting by 5s or by 10s would be more useful. So I'll use counting by 5s for my scale. So now that I have my scale, I'm going to place dots for each value that's represented in the data set. I'm going to mark my scale at every 5th value to make it easier to plot the original data. So my first data value is 1, then 14, 15, 17, 20 appears 3 times, so I should have 3 dots for 20, and then 23 and 26. 31 appears twice, so that's a stacked dot. 33 and 34, 35 and 39 twice, 42, 42, 44 and 48, 50, 51, and 52. So now we can see what the dot plot looks like. And to determine the shape of this distribution, we could try to draw a smooth curve over these dots. So we can see that we have a mound shape for the distribution. Our next problem asks us to consider this given set of data, and from this we're going to create a stem and leaf display of the data set. So the first thing we should do is look at the original values in the data set and take into account what is the digit on the leftmost side, because that will determine our stem. We've got 64, so the leftmost value is 6. 58, leftmost value is 5. So really we're comparing 6 with 5. We want to scan the data set and find the smallest number. That would be the 14. So 1 is our smallest stem, and when we continue scanning we will find that 6 is our largest stem. So we need to include the numbers 1 through 6 for our stems. Now we'll know what to pair up with the leaf depending on what our values are. So 64 represents stem of 6, leaf of 4, because the leaves are the rightmost digit in the number. So with my stem of 6, I know I need to pair with a leaf of 4. 58 is the next value, so pairing stem of 5 with a leaf of 8. 14, stem of 1 with a leaf of 4. 36, stem of 3, leaf of 6. 53 pairs 5 as a stem with leaf of 3. Now I want to make sure I'm writing these from the smallest to the largest, so I'm going to put the 3 in front of the 8 that was already there as a leaf. 59, so that means 9 will go after 8, just so I can keep 3, 8, and 9 in order from smallest to largest. 41 means my leaf is 1. 32, so again 2 needs to go before the 6 to keep it in order. 59, so there's a repeat of 9. And 45, 54, so I've got to squeeze 4, and 47. So what you'll notice is in the stem and leaf, the leaf of 9 repeats itself, and in the data set, 59 is repeating itself twice. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data values, and if you check, you should have 12 leaves, and we do have 12 leaves. So there's my stem and leaf. The second part is to determine the shape of the distribution based on the stem and leaf display. So once again, we can try to draw a smooth curve over our display, and this just happens to be sideways, but that's all right. You can see we've got another mound shape. Our final example today, we are given another data set, and notice the display is a little bit different. It's not in table format. We have the data represents the lifespan in days of 30 houseflies. Describe the data given in the table graphically with a dot plot. On the basis of the plot, make a summary statement about these data. So these numbers represent the lifespan of 30 houseflies. That means we should have 30 data points. And these numbers are also the lifespan in days. So we have 8 days, 9 days, 4 days. You can see there's no particular order here. So if we can place these data values on our dot plot, we can maybe make some sense out of what these numbers represent with relation to the lifespan of a housefly. So we'll need to insert our horizontal line to start with. And since we know what these data values represent, we can go ahead and put a more detailed title on this horizontal axis, lifespan in days, and our title will be dot plot of housefly lifespan. We need a scale, so scanning the data values, try to find the smallest value, 0, and the largest value is going to be 14. So I think I will count by 2s, making sure I go up to 14. Now that we have our horizontal line drawn, and we've got a scale of counting by 2s and a title, we also need to know what this vertical line is representing, and that's going to be our number of houseflies. So we do have a label for our vertical axis. So to make this a little easier to draw the dots, I'm going to make some small tick marks, and each of those tick marks is a count by the scale of 2. So we'll begin with going down each row, 8, 13, and 5, and I'll plot those dots. Then I'll go to the next row, 9, 11, and 8, until we get to the end of our data. So now we have all of our data points plotted, and to make some statement about the placement of these dots, it might be helpful to notice we draw a smooth curve over these dots. Once again, we have our mound shape, so the tallest mound appears at 8, but there's also a pretty high mound or a high bar at 13. So we can see that the lifespan of our housefly really is falling anywhere between 3 to 14 days. So to make a summary statement, we could write the average lifespan of a housefly falls between 3 and 14 days. Looking back at the given data set for problem number 2, I wanted to show you again by hand how to create the stem and leaf display. The stem is going to be the leftmost digits in the number, and the leaf, again, will be the rightmost digit. So we'll start by writing stem and leaf. So we're breaking the number apart. The number 64, leftmost is 6, rightmost digit is 4. So if we scan the numbers, I really want to identify the largest and the smallest numbers first. So that will tell me which stems are needed in this stem and leaf display. So if I scan across, then 64 is going to be the largest number in the set, and it looks like 14 is the smallest. Since 1 is the leftmost digit, my smallest stem will be 1. 64 is the largest number, that means 6 will be the largest stem. I need to include numbers from 1 to 6. So those are my stems. Now I'm going to go one by one and write down the leaves. So with the number 64, stem of 6 pairs with the leaf of 4. 58 means stem of 5, leaf of 8. 14 has a leaf of 4. 36 has a leaf of 6. 53, 59, 41, 32, 59, 45, 54, and 47. So you'll notice there are no leaves pairing with 2 because none of our measurements are in the 20s. But we do need to have the stem of 2 included as that placeholder. Now, the only thing that we need to do to this stem and leaf display is make sure the leaves are in the proper order. 4 is the only leaf, so that's okay. 2 has no leaf. But notice that 6 and 2 are not written from smallest to largest, so we really need to change the order of those. So I'll keep my stems from 1 to 6. So 3 is paired with 2 and 6. I'm not using any commas to separate those, it's just writing the string of digits, no commas. 1, 5, 7 is paired with the stem of 4, and those are in the correct order, so I'll just copy those. So see how I'm lining up the first leaf, lining up the second leaf. Make sure that you're neat about doing this, or you won't be able to see the shape of the data very well. For 5, I need 3, 4, 8, 9, 9. And finally, we only have a leaf of 4 paired with 6. So everything is in order now. If I were to answer part B about what shape the stem and leaf display has, I would try to draw a nice smooth curve over the data. And I can see that that is definitely mound shaped. So when you're drawing your stem and leaf display by hand, we are not drawing any horizontal lines between these stems, and we're not using any commas in between the digits for the leaves.